working on the nadir section of that sarge. This is a video here of Heidi removing a DLA cover. I mentioned that a little earlier. You can see that's a very large, bulky cover. This item below it that Heidi has her hand on right now is the DLA. That's the drive lock assembly. That's the motor that rotates the sarge and locks it in place. We're not actually going to be removing that, but we will be cleaning the areas around it. We have seen on previous inspections that there's filings deposited on some of the motor housings around the DLA and on some of the sarge structure in that area, so we'll use the wet wipes followed by the dry wipes to clean those filings off of the DLA housings and from around those areas. And here we see our sarge test article or structural test article. This is essentially an exact copy of the hardware that's on orbit that was built to perform life testing with. And this video gives you a good indication of the shape of the sarge and the size of the sarge. You can see these gentlemen standing here next to it. You can see the two race rings here, and this is the backside of a trundle bearing. These are the trundle bearing assemblies that we'll be changing out as we do our cleaning and lubing. And that just gives you an idea of how big this ring is and the area that the crews will be working with and the structure that is surrounding it. Next, I have a graphic that I'd like to show you that shows the areas of the sarge we'll be working on EVA3. So again, the red area is cleaned on EVA1, the blue area is what was cleaned on EVA2, and the areas you see in green along the bottom side of the graphic are the areas that we'll be cleaning and lubing on EVA3. Heidi will start back around the cover 13 and 14 area and kind of work her way around clockwise towards covers 15 and 16 and 17 and 18. Steve will be starting down at the very bottom around the cover 19 and 20 area, working his way forward up toward covers 21, 22, then covers 1, 2, and 3. And we'll be doing the same cleaning and lubing steps we've discussed on the previous EVAs. A couple of notes for Steve. Trundle bearing 5 was replaced on STS-124, so when he comes to that one, he'll just remove that trundle bearing, clean the area underneath it, and then reinstall it. Trundle bearing 6 was replaced on EVA1, so the same thing goes for that. We'll remove it, do the cleaning, and then just replace that trundle bearing. We expect that to take the full 7 hours. However, if things go better than expected, we've got some additional tasks that we can have Heidi and Steve perform to take up the remaining time on that EVA. And as Ginger mentioned earlier, we'll then be waiting with great expectations the next morning after we've completed EVA3. We're planning to rotate the starboard sarge 2 full rotations. We'll monitor the currents on and see how much current it takes to rotate the sarge, and they'll also be taking data on the vibrations that are going into the structure as it rotates, and that will give us our first indications as to what the results of all our cleaning and lubrication efforts have been on the first 3 EVAs. The last EVA we have planned for this mission is EVA4. Our spacewalkers for this EVA will be Steve and Shane, and Eric will be our IV. Shane's primary focus for this EVA will be lubrication of the port sarge. Steve will go out to the port sarge to help him get started with that. They've got 6 covers that they're going to remove, and basically this exposes about every other section for on one half of the port sarge. Shane will then lubricate under each of those sections. We'll do a 180-degree rotation of the port sarge that will spread that lubricant around the race ring. And then it will bring the unlubricated portion under those covers we've removed. Shane will then go back and lubricate under those sections. We'll perform another at least 180-degree rotation, and that will spread that lubricant all the way around the port sarge. During that rotation, Shane has a camera that he'll be installing on P1. This is an external television and camera group that we're installing to be in position to support HTV ops next year. Once Steve has helped Shane remove those covers, he will translate back out to the gym. He will reinstall that center disc cover that we left off at the end of EVA1. He'll then translate a few feet over to the forward side of that end cone, and he's going to tuck away a little grounding tab on a wire that has floated up into the field of view of the camera on the end effector of the gym RMS. There's actually two of these tabs. There's only one that's in the way of the camera, but what he's going to do is take both these tabs, kind of twist them together, wrap them around a cable that goes into the side of that camera, and mate the tabs together. There's Velcro on there that will hold those in place, and then if needs be, he'll install a wire tie around that cable and those tabs to help secure them in place. He'll then work his way kind of up the end cone, installing 3 handrails and 2 whiffs, or worksite interfaces. These are the sockets that we plug our foot restraints into on structure. He'll be installing all of those items on the port end cone of the gym. As he works his way on up, he'll just go right on up to the very top of the gym logistics module. There's a location up on top of that where he will install 2 GPS antennas and connect those. Then these are GPS antennas that will be used to guide the HTV vehicle to the space station when it flies next year. Once Steve is complete with that, he will translate back to the airlock, stow the bags he used to carry those handrails and antennas out, and he'll translate just after the airlock to PMA-1, where he'll get into a foot restraint, and he'll use our EVA still camera to make some photos of the S1 and P1 radiators. He will also use an IR movie camera that was originally developed to take IR imagery of the shuttle's wing leading edge RCC panels. He'll use that camera to also film those radiators. This will give us more data for the engineers on the ground to analyze the damage that we have seen on the S1 radiator panel, as well as assessing the health of the remaining radiator panels and see if there's any other indications of problems with those. So with that, I'm ready to show the video that'll show you the areas that we'll be working in on EVA4. Again, we'll start from the joint airlock, translate again up onto the truss. This time both Shane and Steve will be